Welcome to solverfy.
Question number 50 gives us an interesting space-based question where we are told that the cosmic microwave background radiation fills space with a given average energy density, which I have written here as U bar. And we want to find out for part A what the RMS value of the electric field is with what the RMS value of the electric field is for that radiation. And then in part B, we will see how far from a certain radio transmitter we would have to go to find a comparable value. So for this, we are going to go to earlier in this chapter, I believe equation 22-6a, and the formula for the energy density, U, is just epsilon naught times E squared, and the average energy density is just going to be half that value. And then finally, we have to go one further because we want the RMS energy, the RMS electric field, which has a root 2 in front of it, giving us the final relationship of the average energy density just being epsilon naught E RMS squared, which makes sense because it should look like this just for the average RMS electric field. So what we want is ERMS, so we just move things around ever so slightly, and we turn the crank on that, and we get 0.07 volts per meter. So this part is not too hard. The key thing there is knowing not just to use this and plug in your ERMS. For part B, we want to find how far we'd have to go from a 7.5 kilowatt radio transmitter. And that means that we want to take the average intensity formula, which relates an average power with the area. So in this case, 4 pi r squared, because we want to find a distance. And we can set that equal to the formula for the that includes the electric field, which is, I'll write the full thing here, 1/2 epsilon naught times C times E naught squared, but we do the same thing where we replace this with our ERMS, and we see it's equal to epsilon naught C ERMS squared. And we solve for R because that's what we want to find in the end, and that is, I'm going to write it like this, everything under the square root, so power over 4 pi epsilon naught times the speed of light. And I'm also going to put the E squared RMS on the inside of this just to keep everything together. And by doing the calculation there with the given power from the text, it's 7,550 or 7,055 meters, or roughly 7 km. So not too far, all things considered.